Good afternoon to you. Mark Sudduth, HurricaneTrack.com here with your hurricane outlook and discussion for the 7th of July, 2019. I had to make sure I knew what day it was. We got a lot to talk about, so let's jump right in. We will get to the yellow X over parts of the Tennessee Valley in just a moment. Kind of unusual to see that. First of all, it's not showing up here, but the remnants of what was once very powerful Hurricane Barbara are located in here, and I want to show you this. It is important, and if I can get this to go away, that's important too. The satellite presentation here, this is the infrared animation here from Tropical Tidbits. There's the low-level swirl associated with the leftovers, the remnant low of Barbara, and this entire area of clouds and energy, and there's still some energy there, just not much. This is going to go past Hawaii, and it will bring a period of some showers, maybe some heavy rain, an increase in wind, especially on the windward side of these islands through here. So just something to pay attention to if you're heading out that way, or you happen to be tuning in from the Hawaiian Islands. The remnants of Barbara headed your way, and that'll be in the next day or so. Not too much in the way of impact, but there will be some impact nonetheless, and I'm just making you aware of that. All right, in the Atlantic Basin, a couple of things to point out. First of all, look out here in the main development region, a little bit more activity compared to what we have seen. Still, it's only July the 7th, and we have a long way to go. Even a month from now, this part of the ocean typically not that busy even a month from now, so we still have quite a ways to go. But a little bit more in the way of energy coming off from these tropical waves that meander into the eastern Atlantic from the west coast of Africa, some of them originating over the Ethiopian highlands over eastern Africa, believe it or not. A big surge of dust coming off as well overall, and that will generally move west with time and keep the deep tropics closed for the time being. So we now move over to a close-up shot here of the southeast United States, northeast Gulf, and I want to draw your attention to this area right through here. Believe it or not, that is the mid and upper level, or the mid-level energy that is going to be swinging south and east into the Gulf of Mexico eventually, just somewhere around here. That energy in the atmosphere, a mid-level trough of low pressure, maybe a surface trough, more energy in the mid-levels. The bottom line for the layperson, myself included, I'm not a meteorologist, I'm a physical geographer, so I'm an earth scientist, but I'm not a meteorologist, so I don't know all of the mechanisms behind why it is. I am just interested in what it does, okay, and the impacts. And as a geographer, that's my main goal. What's going to develop? Where's it going to go? How strong will it be when it gets there? And what will the overall impacts be? Those are the questions that I ask myself, and then I try to find the answers to. And so for the layperson, which most of us are, you just want to know, okay, what's the skinny behind this? What's the basics? Well, here's the system here, and it's an impulse. It's some energy in the atmosphere. It's a seedling, whatever analogy you want to call it. It is the foundation for which something could develop as this gets down into the Gulf of Mexico. And that's why we see over here on the Atlantic Outlook map the X over portions of the Tennessee Valley. And if we look at this at the 5-day time frame, now a 50% chance of development. And they even mention here in the Outlook here, issued at 2 p.m. Eastern Time, that upper-level winds would support gradual development, and a tropical depression could form late week while the low meanders near the northeastern Gulf of Mexico coast through Friday. So let's take a look at what we've got here. We've got that out of the way. We've seen the broad satellite picture. Again, this is the energy here, but we can also look at this, and I love doing this from a different perspective. Okay, so here's your cloud animation, and we can see it, the water vapor imagery and the cloud cover. Now let's take a look at this from a different perspective, and this is from the University of Wisconsin site. And let's look at that energy in the atmosphere, the vorticity signature. I like to kind of make this analogous to looking at an X-ray. Okay, even though it's not the same thing, this is the way I look at it. So you go in and you say, hey, doc, I got something wrong with me. They do a CT or an X-ray, and they peer inside, and they go, oh, okay, it's this or it's that. It's a bone break. It's a mass growing inside of you, something scary, right? Whatever. And so you get to see through the clouds, so to speak, and this is what we're looking at right here. That is the vorticity, the energy in the atmosphere that I'm looking for. And I got to tell you, that is fairly energized. It's a little bit elongated. You can see that. It's not like it's perfectly round, but it's not diffuse and stretched out like this energy out over the Atlantic. This is associated with an old front or something like that. Or even this system, this energy sitting off the southeast coast. See how this is strung out? So this is more concentrated, especially right around the middle here over eastern Alabama, parts of west central Georgia. And so I do know enough about meteorology and been studying this stuff for 25 years that I know that this is what I am looking for. And so whether this energy is sitting here or if it happens to be over the deep tropics later in the hurricane season, when you get a big ball of energy sitting out here somewhere, you know, where it's nice and concentrated. I'll try to draw on it a little bit. So you start to see some energy concentrated out here, and you've seen it before. You know what I'm talking about. When you see that out in the deep tropics, you know, that's your telltale sign that one of these impulses down in the deep tropics is going to try to develop. And that's the case over here in the eastern Pacific. I hardly even mentioned or didn't mention Tropical Storm Cosme because it's really not an issue. But what I'm trying to show you, and the Weather Channel did a good job tweeting about this earlier today, it doesn't really matter where the energy comes from overall. It matters a little bit because some pockets of energy take longer than others to develop. And I think the most common way are these tropical waves that come off Africa, and those are easier to develop generally than these other systems. So whether the piece of energy is here, sitting out over the tropics, you know, this isn't going to develop because the environment's not good enough. It really doesn't matter. An old frontal boundary can be draped, and you get some concentrated area of convection or vorticity along that frontal boundary, and that's your trigger mechanism. That's your seedling. So there it is. You can see it again over parts of the deep south here, the southeast United States. And again, we zoom in, and now the question is, where does this energy settle into the Gulf? Does it do so real close to land and then come back? Does the energy kind of sit down here and get spread out and stretched out and really never consolidate? That becomes the key. We have identified the vorticity signature, the seedling. Now what happens to it? And whether it stays intact and comes down here and moves west and really starts to solidify or becomes more stretched out like this overall feature will determine what happens. So in that regard, it is a fairly simple concept to grasp. If it stays over water and can concentrate its energy and become more focused, then we will have something that will involve wind, rain, and some storm surge. And that's not a hard stretch to sell at all, because most of this area through here is very storm surge prone, even with 30 knots of wind. So, you know, I'm not talking necessarily a hurricane yet, but a wind, rain, surge event is more likely the more this stays over water. Now, that's just Mark, Captain Obvious, speaking there. I mean, that makes all the sense in the world, right? If it comes out, stays over water longer, bingo, you have a bigger problem. If it stays closer to land and just kind of meanders over here, big rainmaker across this region, and we'll just see what happens. You know, there could be some severe weather, some coastal impacts with rough seas and so forth. So the development part is fairly easy. It's either going to develop into a classic tropical cyclone or it's not. I think that's the easy concept to understand. And then it's a matter of what are the impacts going to be, and that's the harder part of this for me to pin down and any forecaster out there, from the National Hurricane Center to the various Weather Service offices to your local television and other media outlets, the national outlets all the way down to your local stations. That's going to be the hard part. What will the impacts be? First impact will be quite a bit of rain down here. Beyond that, we're going to have to just wait and see as this evolves together. All right, now there's a couple of things that we need to point out. This is the 850 millibar level of the atmosphere. That means we're looking at about 5,000 feet up, and the atmosphere has layers, just like you think about a topographic map of, and speaking of geography and geology, mountains, have elevation, and you have contour lines, and that represents the elevation of the mountains, and you have valleys, so you have positive heights and negative heights when you deal with topography. Same thing with the atmosphere. You have high pressure and low pressure, layers of the atmosphere. This layer, again, 850 millibars is just a way of saying what layer of the atmosphere we are looking at. And again, this is about 5,000 feet up. Now, let's go to the 200 millibar level and beyond. Actually, this is several layers. You can see that indicated right here. 100 to 250 millibars are the blues, and that's pretty high up. 351 to 500 millibars gets down towards the middle layers of the atmosphere, but it's this blue area right through here up to about 250 millibars or so that I'm interested in. Why? Look, what do you see? It's clockwise. An anticyclonic signature with light wind underneath in the middle, all set up through here. Big anticyclone setting up shop, and there comes the system trying to drop into it. If you follow this stuff long enough, you know that is a potential setup for this to develop quickly if it can stay within this area. So here's the impulse right here, and you see that it would drop south potentially. Now all of this is going to change over time. Nothing's just going to stay the same. And so we'll have to see how it evolves. But the models are showing that this anticyclone would be well established with light winds, generally from the east over here, as it drops into that environment. So it could have a rather favorable environment in the upper levels of the atmosphere. The water temperatures are just ridiculous. All of this color through here that I'm outlining in red, sea surface temperatures are 30 degrees Celsius or higher. And I say or higher. It's a little blip of 31 Celsius in there, right up in here near Cedar Key also. Bottom line, the water temperatures at the surface are very warm. In fact, they are a couple of degrees Fahrenheit above normal. And that makes a lot of difference. I don't know if you had your bath set at 84 and then you changed it to 86 Fahrenheit, would you notice a difference? I don't know. But in the ocean, that represents a tremendous amount of energy that is available for tropical cyclones. And you can see that even better when we examine the upper ocean heat content map. Now, this is extremely important because of where the system might go. As it drops down out of the southeast into the Gulf, and if it meanders over here and develops whatever broad area of low pressure, and that low pressure occupies this area, there is ample heat content to work with, as indicated by this shading in here. It's at the bottom of the scale, but it's there. And it'd be a big rainmaker and have some wind and any onshore flow. Yeah, you'd have some surge problems. But if this drops down and then heads over to the west and then comes in, like the Euro shows, and I'll show you that in a moment, the European model, it's a couple things that bother me. You got higher ocean heat content, and especially right here. So, a very, very important key to this, how far south does the vorticity center, and then eventually, and remember the vorticity signature that we're looking at right now is basically in the mid-levels of the atmosphere. Once it drops into the eastern Gulf and develops a surface low, and it will, it's just a matter of how broad and diffuse it is versus how concentrated it becomes. If that drops far south and heads across, I'm just playing hypothetical, the more time it spends over this high ocean heat content, and that's fairly high, that's in the middle of the scale, then we could be looking at something stronger. So this has got my attention a little bit more than it did yesterday. That's the bottom line. I still don't have any clear-cut answers and in terms of definite impacts, except a lot of rain probably coming up for this area through here, and then eventually maybe spreading across the central Gulf Coast. We're going to have to watch this literally on a daily basis. So I talked about the models. Let's take a look at the Ecmwf, regarded as one of the better, more reliable global computer models. And to give you an idea of what's what, here's the eastern United States. We'll outline that for you real quick here. There's Florida. All right. So the impulse of energy, where is it? It is right, let's use sky blue, right there on the initial condition from initialized 12Z July 7th. So that means it was initialized Sunday morning. That's the bottom line. That's what you need to know. There's your energy. That's your piece, your chess piece, if you will. And there's the outline of the U.S., etc. So let's take all that away, and I'll put this frame by frame on each of these tabs. I say into motion. We're going to look at this 24 hours out. Each frame is 24 hours. So this is Sunday morning. Here's Monday morning. Tomorrow morning, there's the energy right there. And you see another little ball of energy. That's Cosme in the Southeast Pacific. Notice how that changes. You'll see what I'm talking about here. That the more round it is, the more energy is focusing. All right? Very, very important to note that. So that's Monday morning. Here's Tuesday morning, and our system starting to drop into the energy dropping into the Northeast Gulf. Still not very well organized. So that's 48 hours out. Tuesday morning. There's Wednesday morning, and then finally Thursday morning. It's a lot more concentrated there in the what would you call that? Almost the East Central Gulf. Okay. Nothing to get alarmed about, but this is 96 hours out, 4 days out, Thursday morning, and it's got a fairly healthy look to it over very warm water. And you notice where that energy is, right there. You see? And again, if we go back to look at that heat content map, right here, wait, I guess I got rid of it. Shame on me. Well, that's okay. It's moving over some fairly high heat content, let's just put it that way. So that was 96 hours. At 120 hours, still sitting over that little tongue of very high heat content. Well, not very high, but high enough. I mean, honestly, it's enough. And south of Louisiana. All right, so that's Friday morning, 120 hours out. And then finally, Saturday morning, even more concentrated there, looking more impressive in the model field as it moves inland over portions of south central Louisiana. Finally, at day 7, we're talking 1 week out. And this is one model run, a deterministic run, the operational model here of the Euro. One solution, just to show you. Okay, now to contrast that, let's go back and let's look at the GFS. So here's the GFS at 72 hours. Okay, so if this is day 7, 6, 5, 4, 3. So here's the Euro at 72 hours. GFS and Euro. All right, so the Euro sitting right in here, kind of like, okay, and GFS, not so much. So pretty big difference there overall in how the energy is handled between the GFS and the Euro. At 96 hours, the GFS, a little bit more concentrated, but you got this energy over here, some of it over here. It's just more diffuse. Now, some can argue that the GFS is notorious for doing this, that it, especially with these types of systems, it's going to spread the energy out. And maybe it's correct, but maybe it is a known model issue. Nobody has the answer to that. Nobody can tell you for sure. I certainly can't. So you look at 96 hours there, and we look at 96 hours on the Euro. Yeah, the Euro is a lot more concentrated and more to the west with that same time frame. All right, so the GFS here at 120 hours out, just kind of a big mess here over the Big Bend area of Florida. You contrast that with the European model at 120 hours, and it's a lot more concentrated and moving more to the west. So you can infer from this that the GFS drops the energy down and just kind of sits here and then eventually comes back. The Euro drops the energy down and moves it off to the west, finally coming in. And there's, there's the UK Met model, which is a blend of these two. I could show you all kinds of models, and we'd be here for an hour. But these are the two sort of big guns out there, the GFS and the Euro. And then you have different iterations of them, part of what are called the ensemble package, where you take the initial condition, in this case, the initial run, and you add and change variables. And in the case of the European, there's 50 other members. It's kind of like having, a solo violinist versus an entire orchestra. The solo violinist may be very good, but until you get the rest of the orchestra involved, you don't have the full sound, if you will, okay, and whatever. And so we could look at that, and again, it would take me an hour, and it just gets too complicated. So what I like to do is simplify it and say, okay, we have some interesting developments here with the Euro. You see what it does there. And, certainly gets your attention. It's hurricane season. We should be paying attention anyway. Is anybody needing to get worried and all worked up about it? No, not yet. I mean, what good will that do you this far out anyway? Just pay attention if you live in this area. And hopefully you're doing that anyway. And the week ahead, do so even more. That's all I'm saying. I'll be on top of it. I'll have a much more, I don't know how much more thorough than this you can get, but another thorough update tomorrow, of course, and I'll take a look at some other things as part of the beginning of the week update, sea surface temperature anomalies, how the El Nino, Southern Oscillation, or the state of the ENSO is doing, et cetera, and so forth. Monday is usually a much larger update overall, and included in that will be this system here, and we'll be 24 hours out, farther along, further along in time, as it were, and we'll know more, all right? So you can follow me on Twitter at HurricaneTrack. I am on Patreon in terms of our support. I can support what we're doing. And I'll be back with more tomorrow. It's going to be an interesting few days as this evolves. And I don't think I have anything else to add. Again, just don't let this get you too wound up. We got plenty of time to watch and see how this shakes out. And between now and then, we'll just see what happens. Hey, I appreciate you tuning in from whatever device you happen to be watching and listening to me on. It's awesome to have you on that side of the screen watching and listening to me. I am Mark Sudduth, HurricaneTrack.com. I'll be back with more for you tomorrow afternoon.